Now let's take a look at the second question on the practice exam. It says, find all numbers c that satisfy the conclusion of the mean value theorem for this function. Okay, so the mean value theorem. And let's try to remember what the mean value theorem says. So we're going to imagine that we have the graph of some function. Alright, so maybe it looks like this. Okay, and the mean value theorem says that if you take, let's get something that you can actually see. So let's pick any two numbers here, a and b. Okay, and just to be clear, let's label this curve as y equals f of x. By the way, this is not necessarily this function. I'm trying to give you the statement of the mean value theorem. So it says if you take the line that connects these 2 points, so hopefully this thing will let me draw a straight line, gives me superpowers. Pretty straight, okay. Alright, so it says that there is some value c between a and b. Okay, so let's make c this ugly ochre color. Alright, and the property that c is going to have is that the tangent line at c is exactly parallel to the secant line between these 2 points. Okay, so what is that point? That point is a f of a, and this point here is b f of b. Alright, and so this green line connecting them is what I'm calling the secant line, and the mean value theorem is saying that we can find some c, or not necessarily find, but there exists some c such that the slope of the tangent line at c is parallel to the secant line. So let me try to draw a parallel line now. Can you forgive me? I don't think I can do it. Let me try again. Control Z. Alright, that's pretty close to parallel, right? Okay. So now this is the picture of the mean value theorem. So what we want to do is, for this function, we are going to actually find a c in this interval, okay, that makes this true. So what they're telling us here is that they want us to use a equals 0 and b equals 1. And I don't know if you know what the graph of the cube root of x looks like. It's not necessary to do the problem, but it looks like this, right? Okay. Alright, and so let's just, for the sake of having a picture, let's put 1 here, okay. And so we're going to have this secant line between 0 and that point, which is going to look like this. And now we're going to be trying to find this value c for which the tangent line is parallel to that secant line. Okay, alright. So we need to know a couple of things. One thing we need to know is, what is the slope of the secant line? Okay, so let's find that first. So let's ask ourselves, what is the slope of the line connecting 0 f of 0 and 1 f of 1. Okay, this is going to be very easy to figure out. So you may know this formula. The formula is m equals f of b minus f of a over b minus a. Alright, and we can plug in these numbers here. So what is this going to be? This is going to be the square root of 1, or sorry, the cube root of 1 minus the cube root of 0 over 1 minus 0. It's the very nice number 1 over 1 equals 1. Okay, so the slope of the secant line here is 1. And if you forget this formula, just do rise over run and you can figure everything out, I'm sure. Alright, and now what? So now we know the slope of the secant line, so now we want to solve f prime of c equals 1 for c. Alright, we just want to find the c that makes the slope of the tangent line the same. Okay, so I've been saying that these two lines are parallel, but that just means they have the same slope, right? And f prime is telling me about what's going on with the slope of the tangent line at a certain point. So the slope of this line is m equals f prime of c, right? And so what I'm saying here is that I just want I want f prime of c to be 1 because that will exactly give me the stuff that satisfies the conditions of the mean value theorem. All that we have to do now is figure out what f prime of x is. Okay, so we have f of x equals the cube root of x, and so what is f prime of x? It's very easy. 1/3 x 2, and what happens when we take 1 away from 1/3? We get minus 2/3, right? Okay, and so now we have to solve. I'm going to use x instead of c. We're so much more used to x. We have to solve 1/3 x to the negative 2/3 equals 0. Sorry, equals 1. Equals 1. Alright, so now you should understand that this is just this. Okay, so we're going to find the value that makes this true, and that's going to give us the answer to the question. So let's just do the algebra. So this means x to the minus 2/3 is equal to 3. This means x is equal to 3 to the minus 3 over 2. Okay, and so what is that? That is, I don't know, it's something terrible. It's a terrible number. But the point is that we are not concerned with the fact that it's terrible, because we just say that the only answer is c equals 3 to the minus 3/2. Okay. Alright, so that was not hard at all. Don't have to draw a picture or anything like that. Let's go back up here and just kind of satisfy ourselves. What happened is that c turned out to be equal to 3 to the minus, is it 2/3 or 3/2? 3 to the minus 3/2. Okay, which is just some number between 0 and 1. And this is the magical one where the tangent line has a slope that is the same as the slope of the secant line. So that is the answer to that question.